The idea is like this, the key-based methodology. First of all, get the IDLE and obtain your, so I'll guide you, then I'll give you time to think. Because like this should go with thinking, right? So it doesn't matter, take your time, but just think a little bit more than you usually think. Okay, so first thing is, let's say you are going to get the plain text. PT, let's say it's PT. You are going to input, then you can say enter a text. This is going to be your plain text, right? That you are going to obtain. Then actually the key, let's say key, you can get again input, enter the key, enter the key. Okay, the first thing that you need to do is count the length of so because you need to match this now, count the length of plain text. So that can be taken. Okay, if I print the length of plain text, it will print the length of it. That is very simple instruction. Let me save this. Let's do one by one. Actually, in this, you are asked two questions. So one will be the plain text. Let's say it is hello world. That is your plain text. And when you type, it asking key, let's type key is, let's say key is DEC 123 is the key. So it's counting the length of hello world. This is 11. Length of the key is also need to be counted. So let's count the length of the key too. Length of key. So what if length of plain text? So what if the length of plain text is more than the length of key? Yes. So what if the length of plain text, this one, is more than the length of key? The key should be repeated, right?
Yes.
The key should be repeated. Okay, so do this now. Actually, I need the key to be, now the key is 6 characters, but hello world is 11 characters. Actually, I need to repeat the key and get 11 times. Actually, deck 1, 2, 3, again deck 1, 2, 3. If you take deck 1, 2, 3 again, there will be 12 characters. I have to take deck 1, 2 only. Okay, think that and try to do that pace. So you have to make the second key length, you have to make it equal to the key length should be equal to the plain text length. So can you try to do that? So what you need to do, you need to repeat, right? You can multiply, right? Even you can multiply key by 2. Then what will happen? Key multiplied by 2. So that will be 2 times of the key. Deck 1, 2, 3 multiplied 2 times. That can be done in Python. Okay, let's try to do that. Let's create a key which matches the size of plain text. First phase is that. Let's try to do that first. Okay, how this can be done? So first of all, you have to compare. If otherwise you cannot do, no. If length of plain text is exceeding the length of key, so then what you need to do, you have to repeat the key, because length of the plain text is higher, then repeat the key. Actually, to find how many times you need to repeat, so simple thing is you can get the v value. So let's make it equal to a variable called v. You can divide the plain text length by this. When you divide that 11 divide by 6, sorry, 11 divided by 6, so that will give something So when you divide 11 by 6, it will give you something that is basically 1 point something. Okay, let's print that. Print that V. So because you need to see how many times you want to multiply this. Find out. Let's give hello world there, and then so this let's put DC 1 2 3. It is 1.8 times. Actually, you have to multiply by the next integer, right? So this can be rounded. This can be rounded. To round that, we can use. So one is floor division. If you use floor division, what will happen? You will get the least number. Here, if you get the floor division, hello world, and let's say take 1 2 3, you will get 1 only. It's not 1.8. To that you can add 1. To that you can add 1 because you know it's getting 1 less than the required amount. So you can add 1 more to that. Actually, that will give the multiplier, right? So that will simply give 2 because this is rounded. This is rounded to the least integer. I'm adding 1 to that to get the next integer. So this is V plus 1 then. So let's run this again. And the text is hello world. And this is DEC 1 2 3 is the key. You can see 2 is the multiplier. When you find the multiplier, the easiest thing is just multiply this key by the multiplier. Let's multiply this. V plus 1 is the key, the length to the multiplier. So let's say M equal V plus 1. This is the multiplier. And let's multiply the key by M. I'm printing the key which is multiplied by M. Okay, that should give, you know, hello world. And deck 1 2 3, you can see deck 1 2 3, deck 1 2 3, but that is exceeding the now actually now what will happen, that is exceeding the length of earlier it was not less than this, but now this is exceeding. So you can get only the required portion by just mentioning the beginning, and the end should be length of this PT. Everything is mathematics here, right? Length of PT is the end point. Yeah, end point is length of PT. Let's see what will happen if I take like this. So we did get the entire string, or hello world. Take 1 2 3. You can see oh. Okay, I have to make this equal to, right? Let's say full key is equal to this into M. Then again you have to say full key is equal to full key is like crop key. Crop key is the portion which is dropped from this, is equal to full key is not taking the full amount. You are taking 0 to length of the plain text. Okay, let's print the crop key now. Print crop key. The crop key should exceed, sorry, crop key should be shorter than the full key. Print full key, and you can print the key as well. Let's to make it more transparent, let's print the key as well. You're printing the key, printing the full key and the crop key. So let's see. So these are the words that I use, right? You can use any name, ABC, or even you can use, it doesn't matter. So just some words. Hello world, deck 1 2 3, and you can see the deck 1 2 3 is the key. Full key is deck 1 2 3, deck 1 2 3 2 times, and the crop key is deck 1 2 3, deck 1 2. It's only 11 characters. Okay, so this is the first page. That is why I said you have to do this page by page. Okay, now you have two strings which are equal. Okay, this is in case of the length is less than, else what you need to do? Else, there can be situations where the length of PT, then you can simply generate the generate the drop key. The drop key is equal to, else the drop key is equal to key. You only take this part. So that is very simple. And then you can print the drop key, right? Actually, they print the key and the drop key. So let's see the second situation also. That is also sometimes can be there. No? Then your plain text is something like hi. So very small plain text. But your key is exceeding that. Dec 1, 2, 3. Then you can see the key is Dec 1, 2, 3, but you have only taken DE. So that is what required here. Right? Dec 1, 2, 3. From that, you are only taking DE. So that is the second way. Like when key is, that means when the plain text length is less than the key length. Okay, you don't want this length, printed length and all. You don't need, right? You can comment or remove that part. I'm just using that for the reference purpose, and you don't want to print the top key, full key also. I'm just printing that just for the why I'm printing, because I just need to show you what is really happening over there. So let's say hello is your plain text, and Dec 1, 2, 3 is the key, and you can see this drop now. In the other way, if you have a long text like hello, I want you by 6-7 p.m. today at night market. Okay, a very big message. Then let's say the key is my key, some small one. You can see here my key is the key. Then my key is the long text, and out of that the top one is this. So which length is similar to the message. Okay, so let's do that quickly and let me know once you are done. Okay, with that part, now you have a matching key, like matching key with the, ultimately at the end you have a matching key. Actually this prop key, let's put it in some variable. So let's put the prop key here. So this is what we need. Initially it is blank. Let's keep that as a blank thing. Initially, later with this, you are generating the drop key. Here also you are generating the drop key. Now you don't want to print the full key, drop key, nothing is needed. Just, you know, that process will happen because we have ensured that we saw that that is happening, that is all. Okay, if it is happening, the next thing is getting the values. So you can do like this for letter, or for letter in the plain text. Okay, you are going to add this character, right, for letter in plain text. Okay, let's say encrypted message, and MSG is the encrypted message. Initially it's empty, and so what you are going to do to this encrypted message is equal to encrypted message plus the new character is this letter. You can just say ORD of the letter. ORD of the letter will take the number value of this, and okay, let's use the other one for letter in range, length of PT. Okay, for letter in range, length of PT, enc message is equal to enc message. Letter should be taken from the PT, plain text, the particular letter, plus you are going to add this. Actually, you are going to add the value ORD, this one. You are going to add ORD of the particular, that is like actually the drop key. Drop key specific character or letter. Specific letter will be added to this, and ORD of this and ORD of this. That is basically the number values. Two number values will be added. So these two number values will be added to the encrypted message. And finally, you can print that encrypted message. Let's see what will happen actually using practical implementation of this. Okay, let's run it. Let's use a very simple one. I'm using hello. Here I'm using hi. Wow, what has happened? Must be str. Everything should be converted to string, otherwise cannot be added. That's the message says. So let's run it again. Hello and hi. You can see these are the values now. This is the encrypted message. Actually, you can print, you can convert that back to not the str, ord, then c. So what is the other way? Ord is converted in a letter to number, then character conversion is how character conversion happens. We discussed that.
CHR.
CH, ORD,
CHR.
CHR. Then it will become a character, so rather than a number. Say hello, hi, and you can see this is what I'm getting now. I'm not sure whether this is correct, but anyway, this is what I'm getting now. Totally jumbled a message instead of hello and hi. Actually, H and H will be added. So let's see this manually. Let's see this manually. What is ORD of H? ORD of H. This is 104. So 104 will be added to 104 here. So total is 208. What is CHR of 208? 104 your deka. You can see this character, right? It is correct. The second H and I will be added. H and I will be added. So what is ORD of H? It is an ORD of I is this one. So when you add 104, 105, it's 209. So what is the CHR of 209? So let's compare this manually, and you are getting neta n. But that is not the one that I got. ORD of E. Let's try to print the prop key. Yeah, it is there. Hi H. Yeah, hi H is there. Then how the encrypted message is generated actually. DPT letter. So initial character is done. It is correct. No errors. HNI 105, 104, 209 is inita. That is the problem. Why that has happened? Okay, the prop key is this. So let's print the ORD of prop key. Now the letter number is 1, right? Yeah, that is 105, obviously. 105 will be added to 100. 105 is added to 109. Here it's not 109. This is E. E is what? E is, sorry, I made the mistake. ORD of H, not ORD of H. ORD of E. ORD of E is 101. So 101 will be added to ORD of I, 105. 101 and 105 means 206. So what is CHR of 206? So you can see it is yes, same. Then next is H. H is 104. Here L. So what is L? ORD of L. 108. 108 plus H is 104. Again, H will be added, no? H 108 plus 104 will be 212. So what is 212 character? It is this character, correct. The next is again L and what is the next character? Hi H. L and I. L and I together I is 105, L is 108, it is 213. Similar, right? 200, small difference is there. You can see this is 230. Then again, I is taken, H is there, H is 104. And here you have, O is, what is the value of O? ORD of O, 111 plus H is 104, then 115. So what is the CHR of 215? It is X. You can see it's X. Okay, everything happens according to our expectation. Right, everything happened according to our encryption. Right now, this is the encrypted message. Now you know encrypted message is this. It uses a key. That is the advantage. Let me run this for a bigger code. Hi, I like you so much. The password or the key is this. You can see the text message generated is this. This is the encrypted message which is generated. Okay, so can you write the decryption algorithm? I have done the encryption algorithm. Decryption should be done by subtracting the particular character value from encrypted text. Can you try to do that quickly? This is just a for loop, just a normal for loop. So can you remember like this, like, okay, for j in range 5. So what will be printed? Print j. So what will be printed here?
5.
5
Numbers to 5.
Only 5?
No, numbers like 1 through 5.
Not up to 5. 0, 1, 2, 3, 4, right? 5 will not be.
Okay.
So then letter in range length of PT. So what will happen? So this is similar to for j in range. The length of something, length of, let's say ABC. So what is length of ABC? Length of ABC is 3.
3.
So then this will be printing 0, 1, 2, right? So I'm just getting the letter like index. 0th letter, first letter, second letter, likewise. For letter in range, length of PT, basically you are, because we don't know what is PT, no? What is the actual length of PT? So let's say this is your plain text. Then the plain text is, let's 0th letter, first letter, second letter, third letter, fourth letter, fifth letter, 6th, 7th, 8th, 9th, 10th. Likewise, it will go up to the length, go up to the last character, right?
Yes.
Right, then what? In here also, actually, you have something like this, no? Let's say your plain text is this, hello. Your ciphertext is hi, hi. This is the, like, this is what the generated, not ciphertext, this is generated key. So you are going from letter in range, length of PT means, what is length of PT here? So let's add, let's use this for the loop and try to understand. So what is length of PT then? If hello is the PT, what is length of PT?
0, 1, 2, 3, 4.
No, I'm asking just length of PT. Length of PT is 5, right?
Yeah.
0, 1, 2, 3. So there are 5 characters, 1, 2, 3, 4, 5. So length of PT will be 5. So this will be going from 0 to 5. So initially it will take letter 0 and add in with prop key 0. So letter 0 is H, prop key 0 is H. Understood? You are getting the PT0 is this. You are getting the prop key 0 is this. H plus H. H plus H, you are getting the number values, add them together, convert it back to the character value. Okay, so what is the number value? ORD H is the number value of the first. Here, the value of this is 104. So value of this is also, that is also H, no? 104. Adding them together, 208. CHR of 208. Understood?
Yes.
CHR of that character. That will be added. So that will be added to the encrypted message. That is the first letter. Secondly, what will happen? This will become 1. This will also become 1. So what is PT1? PT1 is E. What is drop key 1? It is I. E plus I. So E's value plus I's value. So then those will be added together. Then CHR of that will be taken. Understood how this comes?
Yes.
Okay, let me run this. Actually, when you run this, let's cancel this, is not needed. So let's run this, and so this will be running through the loop and hello and the hi. So it will generate this. So what will happen actually? This is hello, then hi, hi, h, then this, after adding them together. Understood?
Yes.
Okay, now which part is unclear? So now what you need to do? You need to find the
Key.
You need to find the plain text. How? Because you know the key. What you can do? You can subtract from this. You can subtract this. That should give this one, right? It's very simple. Okay, do this now. When you know the encrypted message, when you know the key can be removed. Key can be actually deducted from the encrypted message, and then the plain text will be retrieved back. That means you can do this again, but this time you are using a decrypted message, dec msg. So let's say initially it's equal to blank, and the decryption message is the decryption message plus ORDPT letter. Actually, you have to use the enc message, right? Print. Yeah, enc message letter, and then you have to subtract from that the drop key letter. Drop key letter, because you know that, so you can subtract and then find the decrypted message. Let's print the decrypted message. If nothing wrong, the decrypted message should be same as the plain text. Let's put hello and hi, and you can see hello back. So this is what I asked you to do. So is there anything difficult? So what do you think? Is it difficult or unclear? Now are you okay?
I think I'm okay now.
Okay. So please remember these basic loops, otherwise you will not, when I use it somewhere, you will confuse. The for loop is a basic loop, but I'm using this inside some technical stuff. That is why you feel difficult. Okay, just focus on the code just one go. But the thing is that, so if you just see the code somewhere, you won't be able to understand. That is why I'm saying don't so if you try to write this from the beginning to the end at one go, it won't happen. So when a question given, try step by step. Try it step by step. So because like when you see this, and even so you can do this with you can do small experiment with your sister. You can show this to your sister and ask what will happen using this code. Definitely she will confuse, because like when you see that in the first instance, and if you didn't understand what we have done and why we have done that thing, what are these variables, what is this v, what is this, well, all these things will be problems. Okay, therefore building an algorithm should be done carefully, step by step, and so you need to do it. You need to practice a lot to do that. So there will be errors, but if you practice this very well, you can come up with a solution. Okay, the next part. Now, actually one more thing, so that I need to tell. Actually, I couldn't tell this last day. So that is basically libraries in Python. So what are these libraries? Why these libraries are used? Because we have already discussed about these operators. in their behaviors. And we have discussed about the comparison, all these things, sequence selection, repetition. Just this part we have already discussed. Then actually under these control structures also. Okay, so comments in Python we already learned. So comments in Python now is basically, it can be used for two purposes. One is temporary disabling the code by executing, like this code is running. So if you want to temporarily disable it, so let's say this code is running, you want to temporarily stop the decryption mechanism. You can go to the beginning of this line and put hashes. That will introduce comments. And because of these comments, you can see the code related to decryption is not, it's there, but it is commented. As a result, when you run this, it will only run the encryption. Let's say hello and hi. You can see it is only this encryption only. The decryption is not there because I have disabled it temporarily. Temporarily disabling can be done using this hashes. Hashes are comments. So that can be done using comments. Okay, let's see. Let's try for this large message. We didn't try that for a large line. This text is a secret and don't tell this to anyone. Let's say your key is something like this. And you can see, so this is the encrypted text. It is generated immediately by repeating the key and then adding the corresponding values. Right, then commenting is basically temporary disabling. You can enable that and disable that anytime that you want. Another usage of comment is to explain the codes. So if it is required to explain the code segment, still you can use a comment. And there is a way of applying multi-line comments, but in Python, you don't have any multi-line comment styles, but still you have a cheat. Cheat means not a good one, but still it will work. That is introducing three single quotations. Then it will think this as a text part. Three single quotation. So that will think this as a text part. End of this, you can again use three single quotation to finish. So this entire section will be commented. This is not a comment actually. It will think that as a string. Therefore, it will be kept isolated in the memory. It won't run. That is multi-line comment. Actually, this is, so there are multi-line comments in other languages, but in Python you don't have. Therefore, we are using this as a cheat. This is not originally this is not a multi-line comment. You have only the single line comments in Python. Okay, the next is code libraries. So that is the last one we are going to discuss for today. Code libraries are actually specially developed code segments. These segments can be developed by the vendor itself or the programming language provider itself. So maybe Python, they have developed this library. So there are some external people or there are some programmers developing these code libraries. So these libraries, example libraries means already created codes. Math, NumPy, Turtle, Kinter are some libraries. So let's see this code segment. I'm going to copy and paste. You can also try this in a new file. So let's write down this in a new file very quickly. Take a new file and write down this. Let's see what will happen now. So what is the expected results when you run this? So what was there? Actually, this Kinter library or the TK or the Kinter library is basically referring to the graphical user interfaces. When you run these, so let's save it and run. When you run this file, you can see there will be a window appearing that says hello Kinter. So this is basically the geometry for 400 by 300 is the window width and height, and hello is the window title. Then the label is basically showing hello Kinter, and this is what the library is. Library converts. Actually, library is basically developed for graphical user interface. And let me show another library too. So you can include like multiple libraries. Adding multiple libraries is possible. Let me import another one. I'm importing a library called turtle. So let's say t equal turtle dot turtle. I'm creating a turtle object. Then let's say for k in range 10. T dot forward, let's say 100 pixels, and T dot left side, let's say 127 degrees, forward 100 pixels, turn left 127 degrees, again forward 100 pixels. This should happen 10 times. So let me run this code. And see what happens. So the second library is turtle library. The first library is Kinter library. The second library is turtle library. You can increase the number. Let's increase number to 40. You can see the first one gives the window. The second one gives the illustration of the drawing. So that is another library. So these are the libraries. These are only some libraries available in Python, but there are many. We can do many like scientific researchers, graphical user applications, game development, so website scripting, hacking, network management. For most of the reasons, we can use these libraries. So different reasons, there are different libraries too. For scientific researchers and the number-based researchers, NumPy is a library. Likewise, for different tasks, there are different libraries. And we can combine them together too. Okay. Right?
Yes.
Okay, then I'll stop from here for today. We have discussed about the libraries and commands, as well as we discuss about the loops, how we can use loops for encryption, decryption tasks. So that also we discuss. Please do practice these things continuously, otherwise you will forget. Okay, so let's stop from here. Then good night.
Goodbye.
Bye. Bye. Okay.